Hello everyone. Today we're going to be doing a nice little complex numbers slash polynomials problem. So namely, we're supposed to find a cubic polynomial with real coefficients such that p of 1 plus I is equal to 3i minus 4 and p of negative I is equal to 4 times I minus 1. And of course, I is the imaginary unit. Okay, so how do we go about doing this? Well, first of all, let's go ahead and write the general form of any cubic polynomial. So p of x must be equal to ax to the third power plus bx squared plus cx plus d. Okay, now instead of p of x, first we're going to plug in p of 1 plus I, which is equal to 3i minus 4. So 3i minus 4 is equal to a times, and instead of x, we're going to plug in 1 plus I to the third power plus b times, instead of x again, 1 plus I to the second power plus c times 1 plus I and plus d. We're going to do the same thing with the other condition. So instead of p of x, we're going to put in p of negative I, which is equal to 4i minus 1, which is equal to a times negative I to the third power plus b times negative I squared plus c times negative I plus d. Now, in order for this to be written as concisely as possible, I'm going to calculate the powers of 1 plus I and negative I, respectively, below. So 1 plus I to the first power is just 1 plus I. There's no need to do that. Let's go ahead and do 1 plus I to the second power. So using the formula for the square of a binomial, we know that it's first squared plus 2 times the first times the second, which is just 2i, plus the second squared, that's plus I squared, but we know that I squared is negative 1. So these two will cancel out, and we're just left with 2i. Now, 1 plus I to the third power is exactly equal to 1 plus I to the second power times 1 plus I. And we know from the last step that 1 plus I to the second power is equal to 2i, so we're just going to plug that in here. So 2i times 1 plus I is equal to 2i plus 2i squared, which is just negative 2. Okay, now let's go ahead and do the same thing for negative I. Negative I squared is exactly the same as I squared, which is equal to negative 1. Negative I to the third power must be equal to negative I to the second power times negative I to the first power. So this is minus 1 times minus I, and this is just I. Now that we know these facts, we're just going to plug in these values, right, into equation number 1 and equation number 2. Okay, so 3i minus 4 is equal to a times 1 plus I cubed, which is the same as a times 2I minus 2 plus b times 1 plus I squared plus b times, and we know that this is just 2I, plus c times 1 plus I plus d. Okay? Now, of course, we can rewrite this as 3I minus 4 is equal to 2a times I minus 2a plus 2bi plus c plus ci plus d. And let's go ahead and factor everything on the right-hand side in terms of I. So 3I minus 4 is equal to, what has I here? This, and this is equal to 2a plus 2b plus c times I minus 2a plus c plus d. And when we set the real parts, the real parts of the left hand and right hand side to be equal, and when we do the same with the imaginary parts, we'll get two equations. So the first of those equations is going to be that 2a plus 2b, let me just write that a little prettier. So 2a plus 2b plus c is equal to 3. And negative 2a plus c plus d is equal to negative 4. Okay, so these two equations constitute the first part that's going to help us. And let's go ahead and do the same thing with the other two values, namely by using them in equation number 2. So we'll get that 4I minus 1 is equal to a times negative I cubed, which is just I. So that will give us AI, and what are we going to have next? Plus b times negative I squared, which is just going to be negative b minus ci plus d, and let's go ahead and rearrange this one as well. So that will give us a minus c times I minus b plus d. And from here we're going to get the other two equations. So a minus c must be equal to 4, and negative b plus d is equal to negative 1. So now we've got a system of 4 linear equations with 4 unknowns. So let's just go ahead and try and reduce this a little bit. Okay? So how can we solve this in the most elegant way? Well, from the first equation, from this equation, we can say that a is equal to c plus 4, and from the other one we can say that d is equal to b minus 1. Now let's just go ahead and plug that in to these two equations. So instead of a, I'm going to write 2 times c plus 4, which is 2c plus 8, 2c plus 8 plus 2 times b plus c, and that's just equal to 3. And for the second one, minus 2a, which is minus 2 times c plus 4, that's going to be minus 2c minus 8, minus 2c minus 8 plus c plus d, which is just equal to b minus 1. And all of that is equal to negative 4. Now let's go ahead and rearrange these two equations just a bit. So c, that's 3c plus 2b, that's 3c plus 2b is equal to 3 minus 8, which is negative 5. And in the second one, we have negative c plus b is equal to negative 9, so this must be equal to 5. Okay, so this is equal to 5. Okay. Now, from here, from this equation, we get that b must be equal to c plus 5. So we're just going to plug that into this equation, and that's going to give us that 3c plus 2 times b, which is 2c plus 10, is equal to negative 5. So 5c is equal to negative 15. So from here, c must be equal to negative 3. Okay, that's one of our answers, one of our coefficients. From here, and from this here equation, we get that b, which is equal to c plus 5, that's minus 3 plus 5, which is 2. And now we can, of course, find the values of a and d as well. A is equal to c plus 4, so that's negative 3 plus 4, so a must be equal to 1. And d is equal to b minus 1, so that's 2 minus 1, which is just 1. Okay, now we have all of our coefficients. So that means that the polynomial, that the third degree polynomial, must be a times x cubed, which is just x cubed, plus b times x squared, so x cubed plus 2x squared, plus c times x, that's minus 3x, and plus d, which is just 1. So this is our final solution to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.